For nearly a century, one particular stone at the heart of Stonehenge sat as the last unsolved piece of a 5,000-year-old puzzle. Every other major stone in the monument had a known origin somewhere in southern Britain. This one didn't match anything. In 2024, a team of geologists ran its mineral fingerprint through a systematic computational comparison against geological data from across the entire British Isles, expecting to close the case for good. Instead, the results pointed somewhere nobody had seriously considered. A region more than 700 kilometers away in the far northeast of Scotland. That means a 6-ton slab of rock made a journey longer than the width of the entire country, without wheels, without draft animals, strong enough for the terrain, thousands of years before anyone had a reason to write any of it down. And that discovery turned out to be only the beginning of what modern data analysis is finding hidden inside Stonehenge. Stonehenge sits on the open chalk grassland of Salisbury Plain in Wiltshire, England, roughly 90 miles southwest of London. And for most of the last several centuries, the monument's biggest problem for researchers wasn't a lack of interest, it was a surplus of guesswork. Medieval writers credited its construction to Merlin and to giants because the scale of the achievement seemed impossible to attribute to the people who actually lived on that plain. Radiocarbon dating eventually settled the basic timeline, and what it revealed was not a single heroic construction project completed in one generation, but a site built up gradually across an enormous span of time, roughly from 3000 BCE to 1600 BCE, in distinct phases separated by centuries. The earliest phase consisted of a circular ditch and bank enclosure along with a ring of 56 pits set just inside that earthwork, known today as the Aubrey Holes, named after the 17th century antiquarian John Aubrey, who first identified them. Centuries later, the massive upright sarsen stones and their horizontal lintels were raised, forming the iconic outer ring and inner horseshoe that most people picture when they think of Stonehenge. Locked together using mortise and tenon and tongue and groove joints, woodworking techniques translated into solid stone by people working without metal tools. Layered in among the sarsens sit the smaller bluestones, rearranged multiple times across different phases of the monument's use, in configurations that still aren't fully understood. The site was eventually closed down in an orderly way around 1600 BCE, not abandoned in a hurry, and it sat largely undisturbed on that plain for the following 3,500 years, waiting for someone with the right tools to start actually reading what was in front of them. The most basic, stubborn mystery about Stonehenge has always been the sheer physical difficulty of what its builders accomplished. The outer ring is built from sarsen stones, a hard sandstone, each one standing more than 20 feet tall and weighing around 25 tons. For most of the monument's modern study, their exact source remained a matter of debate, until a 2020 study led by geomorphologist David Nash and his research team applied portable X-ray fluorescence analysis directly to the stones, then cross-referenced the chemical signatures against sarsen deposits across southern England using a systematic data matching process. The results pointed to West Woods, a site in Wiltshire roughly 15 miles from Stonehenge, finally resolving a question that had lingered since antiquarians first started asking it. The smaller bluestones tell an even more demanding story. Since the 1920s, when geologist H. Thomas first identified their chemical composition, researchers have known that these stones, some weighing up to 4 tons, originated in the Priestley Hills of southwest Wales, roughly 140 miles from Salisbury Plain. That distance alone represents one of the most extraordinary feats of Neolithic engineering ever documented. Moving multi-ton stones across that kind of terrain, over hills, across rivers, without wheeled vehicles, without draft animals capable of hauling that kind of weight using only rope, timber, and raw human effort, remains something modern. Experimental archaeology has only partially been able to replicate under controlled test conditions. Teams that have attempted to recreate the process using period-appropriate technology have succeeded at smaller scales, but the logistics of coordinating that kind of movement across 140 miles of unpredictable Neolithic landscape still leaves researchers with more respect for the achievement than concrete answers about exactly how it was organized. All of this made the one remaining unidentified stone at Stonehenge, known as the altar stone, into one of the longest-running unsolved questions in British archaeology. Lying flat near the center of the monument, this 6-ton, 5-meter-long slab of gray-green sandstone had always been loosely grouped in with the bluestones simply because nobody had a better category for it, despite its composition being visibly different from anything else on site. For decades, researchers assumed it likely originated somewhere in the Anglo-Welsh basin, broadly consistent with the bluestones' Welsh origin. But that theory never quite fit the data cleanly, and a series of studies through the early 2020s progressively ruled it out entirely. In August 2024, a research team led by geochemist Anthony Clark of Curtin University in Australia published findings in the journal Nature that finally cracked the case, using a far more rigorous approach than anything applied to the stone before. Rather than relying on visual comparison or general geological classification, the team analyzed the age and chemical composition of microscopic mineral grains, specifically zircon, apatite, and rutile, embedded within fragments of the altar stone, then ran systematic comparisons against sedimentary rock databases covering the entire British Isles. The computational matching process returned a result the researchers themselves initially found hard to believe. As lead author Clark has described it, the first batch of data looked so distinctly inconsistent with any source in southern Britain that the team assumed an error, reran the analysis, and got the same answer again. The mineral signature matched with remarkable specificity a geological formation known as the Orcadian Basin, located in the far northeast of Scotland, an area that stretches from the Scottish mainland out toward the Orkney Islands. That result means the altar stone traveled a minimum of about 430 miles, and by some estimates, closer to 466 miles, from its point of origin to Salisbury Plain, a distance dramatically farther than either the Sarsens or the bluestones needed to travel, and one that researchers openly admit they cannot yet explain. The study's own authors have been direct about the limits of what their data can tell us. Their geochemical analysis identifies where the stone came from with a very high degree of confidence, but it cannot answer how Neolithic people transported a 6-ton block that far, and it cannot answer why they went to such extraordinary lengths to bring this specific stone from this specific remote part of Scotland, rather than sourcing comparable material somewhere closer. Researchers studying the logistics have noted that overland transport across the densely forested terrain of that era would have been extraordinarily difficult, which has led some to propose the stone may have traveled at least partly by sea, an equally daunting prospect given the maritime technology available at the time. As one archaeologist not involved in the study, Susan Graney of the University of Exeter, put it publicly following the paper's release, the finding underlines connections between two regions of Britain that had, until this point, remained largely hypothetical. While geochemistry was unraveling where Stonehenge's stones physically came from, a separate strand of research has spent decades trying to explain why the 56 Aubrey holes exist at all, and why that number specifically appears in the design. The pits themselves are unevenly spaced, some containing traces of cremated human remains, others found empty, a pattern early researchers were inclined to write off as simply imprecise Neolithic construction. But in the 1960s, astronomer Fred Hoyle and separately engineer-turned-astronomer Gerald Hawkins proposed something more deliberate. The moon's orbital path, relative to Earth, shifts through a repeating cycle lasting approximately 6 years, a phenomenon known as the lunar nodal cycle, which governs the timing. The hypothesis has never achieved full, unanimous acceptance across the archaeological community, and it remains genuinely debated, with some researchers pointing out that the physical spacing between individual holes is not perfectly uniform enough to prove deliberate encoding beyond doubt. But the underlying mathematical relationship, 56 pits, 3 lunar nodal cycles, is real. It is not coincidental in the way skeptics originally assumed, and it points toward a level of sustained generational astronomical observation that would have required tracking the moon's rising and setting points across the better part of 2 decades, passed down and cross-checked by multiple observers before a single pit was ever dug. Stonehenge's relationship with sound has also moved from folklore into genuine, testable science, though the real findings are considerably more measured than the version that tends to circulate online. In 2020, acoustic engineer Trevor Cox at the University of Salford led a research team that built a precise scale model of Stonehenge as it would have appeared when fully intact. All trilithons standing, every lintel in place, then used that model to run controlled acoustic testing. The results showed that a complete Stonehenge would have functioned as a genuine architectural sound environment, producing a measurable reverberation time of a little over half a second inside the circle, comparable to the acoustics of a modern lecture hall or classroom. Sound generated inside the ring, voices, music, ritual activity, would have echoed and been amplified in ways distinctly different from standing in the open landscape surrounding the monument, while sound generated outside the ring would have been noticeably dampened for anyone standing within it. This is a real, published, peer-reviewed finding, and it is genuinely significant because it demonstrates that whoever designed Stonehenge's layout was working with an intuitive, practical understanding of how enclosed stone structures shape and hold sound, whether or not they possessed anything resembling a formal theory of acoustics. What the research does not claim, and what remains firmly in the territory of online speculation rather than established science, is any specific finding about infrasound frequencies designed to induce altered mental states or trance. The genuine acoustic research describes an architecturally significant reverberant space, comparable in principle to the acoustics later built deliberately into cathedrals and concert halls, not a mechanism for manipulating human consciousness. Perhaps the most transformative use of large-scale computational analysis at Stonehenge came not from studying the stones themselves, but from studying the ground around them. Between 2010 and 2014, a research initiative called the Stonehenge Hidden Landscapes Project, led by archaeologist Vincent Gaffney of the University of Birmingham, in partnership with the Ludwig Boltzmann Institute in Austria, conducted the largest non-invasive archaeological survey ever attempted at the site. Rather than digging, the project deployed ground-penetrating radar, magnetometry, and other remote sensing equipment across roughly 12 square kilometers surrounding Stonehenge, generating an enormous volume of geophysical data that was then processed and mapped using computational software capable of detecting subsurface anomalies, invisible to a person simply walking the landscape. What emerged from that data reshaped how researchers understand the wider region. The survey revealed dozens of previously undocumented archaeological features buried beneath the surface, including new henge monuments, burial mounds, and, most strikingly, evidence at nearby Durrington walls of a massive prehistoric enclosure now understood to be one of the largest Neolithic monuments ever identified in Britain. Follow-up research published in 2020 went further, identifying a ring of more than 20 enormous prehistoric shafts, some over 10 meters wide and 5 meters deep, arranged in a circle roughly 2 kilometers in diameter around Durrington walls, dated to approximately the same era as Stonehenge's major construction phases. Researchers involved in that discovery have described it as evidence of a coordinated boundary marking out a significant portion of the surrounding landscape, on a scale that requires real surveying capability to lay out accurately across that much terrain, even though the exact purpose of the shafts themselves remains an open question. None of this points toward some singular, secret geometric megastructure connecting every regional monument into one grand design, a claim that goes well beyond what the actual survey data supports. But it does confirm something the data processing technology made undeniable. Stonehenge was never an isolated monument standing alone on an empty plain. It was the most visible piece of a much larger, deliberately organized ceremonial landscape that simply couldn't be seen or understood until modern computational tools were pointed at the ground surrounding it. Put all of this together, and the honest state of Stonehenge research in 2026 looks less like a mystery being closed and more like several very old questions finally being asked with better precision. Researchers now know with a high degree of geochemical confidence exactly which regions of Britain produced the sarsens, the bluestones, and the altar stone. What they still cannot fully explain is the logistics behind the most extreme of those journeys, the 400-plus mile route the altar stone took from northeastern Scotland, a transport challenge that current experimental archaeology has not been able to convincingly replicate or fully model. They know that the monument's design incorporates real astronomical alignments, the summer solstice sunrise being the most famous and secure, alongside a genuinely compelling, if still debated argument connecting the 56 Aubrey holes to lunar eclipse cycles. What they don't know is how consistently or how precisely that knowledge was actually used and maintained by the generations of people who kept the site running for roughly 1,400 years. And they know, thanks to geophysical survey technology, capable of mapping what the naked eye never could, that Stonehenge existed within a coordinated ceremonial landscape stretching for miles in every direction, while still not knowing the full purpose that landscape was built to serve. None of this requires inventing a hidden, forgotten supercivilization to feel genuinely remarkable, because the real, verified data is already strange enough on its own terms. A community of Neolithic farmers, working without metal tools, without wheels, and without any writing system we have ever found, coordinated the movement of multi-ton stones across distances of over 140 miles in one case, and more than 400 in another, embedded astronomical observations spanning decades into the physical spacing of buried pits, and built a stone enclosure that measurably altered how sound behaved inside it, all while apparently expanding the site's significance across a surrounding landscape, large enough to require real surveying skill to lay out accurately. Modern geochemistry, acoustic modeling, and computational landscape mapping haven't handed us a finished answer about why any of this was built. What they've done is strip away centuries of guesswork and hand researchers a set of precise, verifiable, and still genuinely unresolved questions about a monument that has spent 5,000 years sitting quietly in a field in southern England, patiently waiting for the tools capable of actually reading it.